Welcome back. In today's tutorial, we are going to look at how to supercharge your NestJS application by integrating large language models locally using Llama. Running model locally means zero API cost, complete data privacy, and offline capability. To get started, make sure the Llama daemon is active on your system. Once your environment is running, open your NestJS project directory in your terminal and install the official Llama client package via NPM. This package are a lightweight wrapper that communicates directly with Llama local engine, allowing us to manage conversion seamlessly with minimal boilerplate. Now let's look at the code base. In this architecture, we are injecting our AI feature directly in a controller. We import a standard character from NestJS command alongside the default response from the Llama package. Let's implement a get endpoint named Llama. It captures an incoming JSON request body containing a user message. Inside the asynchronous handler, we invoke ollama.chat, especially passing our selected model. When choosing an open source model from Llama, your design should be dictated by your system RAM and VRAM. As a rule of thumb, 7 billion to 8 billion parameter model like Llama 3 or Mistral require minimum of 8 GB of unified memory or VRAM, though 16 GB is highly recommended for smooth real-time generation. 14 billion to 22 billion parameter models require 16 GB to 24 GB of VRAM. 20 billion plus parameter models reserved for workstation setup with 48 GB to 64 GB plus of memory. For standard development laptop with 16 GB of RAM and 8 billion parameter model optimized with 4-bit quantization, offer a perfect balance between processing speed and contextual accuracy. But in here, I will use only Gemma 3 4 billion. By default, it will return the entire response object as shown here. NestJS relies the complete payload metadata. Let's send a test request to see exactly what this object contains. Testing this endpoint in Postman with a simple payload return a detailed response. The local will process our prompt and yield a structured JSON object. Inside the payload, you can review crucial execution metrics, total duration, telling you how long the operation took, load duration, and the main message object containing the assistant text content. While receiving the entire payload structure is incredibly useful for debugging performance or tracking token distribution. Your front-end application usually only needs the actual text reply. To clean this up, we can modify our return statement to target the text value explicitly. If we re-execute our request in Postman after making this adjustment, the endpoint bypasses the background metadata entirely and serves a clean, user-friendly string response. This makes it instantly ready to display in your user interface. With just few lines of code and efficient localized model footprint, your NestJS application can run completely independent AI workflows. If you find this setup helpful, hit the like button, subscribe for more backend architecture, and I see you in the next tutorial.